Hello everybody, and welcome back to another lesson. Last time we created the bubble animation for our steam boiler. Let me open the thing quick. It's very laggy, so I pressed it once and it's frozen. So, we also made it so that the water level for the top of the tank is moving because water is coming in and out of that sphere. So that's what we did. And what we're going to do today is I have to turn the animation on. What we're going to do today is, oh, you can see the bubbles. Start making a wobble for the bubbles. So the bubbles here. One of the problems is that they're not that realistic. So we're gonna make them more realistic by making them wobble a bit more. So let's start. We'll start doing that. So obviously we have to start our code before the scene timing. Let's add our def add wobble driver. Our wobble driver is basically we insert lots and lots of parameters and it just spits out a result. Our parameters are object, most likely it's going to be the bubbles axis index, so x or y, because we want to wobble it either this way, which is x, or that way, which is y. So we're going to define that base value, which is just kind of where they wobble around. So like if they wobble in the middle, then the base value is just they have amplitude. So how far is the farthest wobbling point? So the farthest they wobble, we define that. Frequency, phase, and frame, and FPS. The last three we're gonna get into more later. I'm not gonna tell you what they are just this second. So now let's add a comment that tells us what we want to do. A driver takes as input, takes the frame number plus some other inputs. So the frame number is, well, FPS is frames per second, but it's phase. Pretty sure. And then use an equation to change a specific amplitude. Actually, we're going to actually create a equation and just comment 2 pi frequency times frame divided by FPS plus phase ty of the object. So in this equation we have frame divided by FPS, and if you know things, if you can put stuff Well, if you put two and two together, you can figure out that this is the seconds, so we need the number of seconds in our equation because we have frame and then how many frames are in a second, so 24 frames is 1 second, and then yeah. Next, and we keep going. In this case, the other inputs are frequency, phase, amplitude, and base. The to be changed property is location because it wobbles, so the location changes. The equation is obj.location axis index, so x or y goes base. Let's go to plus the amplitude. Well, random number between the base and amplitude. Alright, now we're done with this comment. We can move on to more comments. Axis index is equal to 0 is x, y, 1 is y. So over here, if we enter a 0, we're telling them to wobble on the x-axis, and if we use put in 1, we tell them to rotate to wobble the y-axis. Base value, which so we're just defining the parameters so we can figure out what they are in the future. So base value, I already said what it is. It's the center position to wobble around. Amplitude, wobble, amplitude, wobble, amplitude in meters. I'm gonna put parentheses around that. How far is the farthest wobbling point away from the base? Frequency is frequency in cycles per second, not per frame, per second. So that's where this is. Frequency, may be wondering what cycles per frame. Well, you'll find out. We first use frame divided by FPS to convert the frame to seconds. So yep. Then we use 2 pi times frequency times frame divided by FPS to get the angle. Angle? Where did that come from? I thought we were just talking about like distance in the wobble. Well, that's where this part comes in sine. And we'll get into that. The phase is the starting angle, radius. So bubbles don't all wobble in sync, because if the bubbles all wobble at the same time, that doesn't look very realistic too. Now let's define a variable. FCU is equal to obj dot driver add location axis index. So over here we have a driver, which we have the location and also on the x or y, and then we make another variable like this so we can, make an expression. which we'll have, but we had in the beginning. Driver dot expression is equal to f base value plus amplitude times sine 2 times pi times frequency, and the frequency times frame divided by FPS. So the seconds, and U plus phase. Okay. You may want to know what this is, and that is what we're going to get into in the next lesson. This is actually it for this lesson, so bye.